Okay, so it's indeed a great pleasure to have our colleague with us as an eminent speaker to uh, to commemorate, the 75 years of India's independence. As you all know, that we are organizing a series of talks. Every month we have a speaker who of distinguished category who delivers talks of general interest. And we had several talks earlier, and then this is one of those in this series. And for those who are not familiar with Professor Baskaran, I would like to introduce him to all of you. Professor Baskaran is a theoretical physicist from Institute of Mathematical Sciences, our institute in Chennai. Currently, he is a distinguished professor at IIT Madras and also holding distinguished visiting research chair at Perimeter Institute for Theoretical Physics, Waterloo in Canada. He is known for his works on theory of superconductivity, strongly correlated electron system, quantum Hall effect, fluorescences, graphines. PMW and Anderson and Baskaran pioneered the RVB theory of high temperature superconductivity. When we were students, these were the talk of the physics community. And Baskaran has predicted unconventional low temperature superconductivity and room temperature superconductivity in some systems. Continues to be intrigued by biology, from nanoscience to quantum processes in biological systems. He's one of those who actually, with whom you can talk anything. He is extremely knowledgeable in every area of science, also in other areas. Those who have interacted with him will agree with me. He educated at Madurai and a PhD from Indian Institute of Science, Bangalore. He has been closely associated with Abdul Salam International Center for Theoretical Physics, ICTP, Trieste, Italy, Princeton University, Princeton, USA, Perimeter Institute of Theoretical Physics, Waterloo, Canada, and IIT Madras, and many other institutes in India, abroad. There are plenty to name, actually. And he won ICTP prize, Alfred Keister Award. Physics was awarded to Baskaran in 1983. He received Shanti Swarup Bhatnagar Award, prestigious one from India, and in 1990, and Sastra and G. N. Ramachandra Award in 2019. He got Distinguished Alumni Award of IISc Bangalore and Tyagaraja College, Madurai, a Fellow of Indian National Academy of Sciences and Indian Academy of Sciences. He is also Fellow of the World Academy of Sciences. He writes articles and gives popular science talks in Tamil. And we're really happy that he's with us to talk about some of the very interesting topics, and will, I hope, not only inspire us, it will inspire everybody from a younger generation. Thanks, Professor Baskaran, and I'll leave it to you.
Thank you, Ravi, for a kind introduction. And I thank Ravindran and Arijit and Vishwanath for inviting me to give this talk. I really feel honored, and I'm happy to be talking to my colleagues and others. So before I begin my talk, I should also thank Math Science and IIT Madras and Perimeter Institute for tolerating me. And so it has been a pleasure working here. So today I chose this topic, out of the box science, some inspiring recent examples. And after giving the topic's name, I found that out of the box science also means something else. So you will see what I wanted to say in my talk. We are celebrating 75 years of India's independence. Given our population, history, and the complex cultural landscape, it's fair to say that we are an young democracy. In fact, recently I was talking with a politician, and I convinced him that we are really an young democracy because he was very unhappy about happenings. I told him these things will happen because we are young. So on this happy occasion, let's remember that there is a long way to go. We have to work together with optimism and hope towards a unified world of many nations without borders, a happy, green, and healthy earth, an utopia. That's my vision. Everybody else's wish also. Okay. Having said that, this is what I plan to do. So, some introduction, I will give inspiring living examples, many of them next door. In fact, I have not informed any of them that I am going to, say something about these friends that they will come appear in this. So, science is a liberating force and a new hope for society. It elevates us and at the same time humbles us. It's amazing that once you learn a little bit about astronomy and about various things, you see in the time scale we are a dot, and in the spatial scale also we are a dot. And from Planck length all the way to the size of the universe, there are so many orders of magnitude. We are nothing actually. But at the same time, science gives us power to do whatever we could do within our limited time scale and length scale and the in the planet that we have. So no other force has united humanity so much. It's also heartening that scientists are messengers of peace. And of course, it's for us to decide whether science is used for construction or not for destruction. This is a continuing debate which will keep happening. Okay. Now, I will discuss some inspiring examples of scientists about whom I have often felt I wish I could do what they are doing. That's the way I have chosen them. Most examples I have planned to discuss are individuals whom I know personally. Some of them, out there in the big world, there are many more such inspiring examples. In fact, with time I find there are many, many good people doing wonderful things around the world. We don't recognize them. So there is a lot of hope for optimism. Okay. So I'm going to talk about scientists who are doing science, their regular science, applying science to real life issues, and supporting science and nurturing it directly or indirectly, somewhat out of the box. That's the theme of my talk. So let me start with in-house examples of nurturing science. See, math science, many of you, as you know, many of you outsiders, is well known for going beyond science and nurturing science in many, many ways. Since I joined in 87, I have been enjoying this, occasionally participating in science activities for school children, teachers, and the dedicated works over decades by colleagues, T.R. Govindarajan, Jam, Indumati, Kamalodi, and several others, and literacy program, Tamil Nadu Science Forum activities. In fact, recently, I was very excited by a work by, in fact, I request people to look at the website of Manu Prakash. He is a young professor at Stanford University. Ramchandran, Professor RR will be happy to know that he was an IIT Kanpur product. He is doing wonderful things in biology, and also he has made something called a foldscope, a $1 microscope which people can see the microcosm. So, and I found from my email, I have been getting interested in it recently. Then in 2016, my colleagues at Math Science have done a workshop. At that time, either I was away, I was totally unaware of that. I just saw the email. So we have been doing, Math Science has been very active in addition to the wonderful science it does in these things. For example, if you look at Tamil Nadu Science Forum, many of our colleagues are deeply involved. Tulir, Janta Mandar, both brought out by Tamil Nadu Science Forum. And Indumati is the editor of this Jantar Mandar. And they have other things. It's amazing, they outside their regular research activity, many of these things are being done. And so this is some example. Then recently I was very pleasantly surprised to hear from our friend Venkatesh Raman. So among the continuing efforts from Math Science faculty, there is a recent effort from Venkatesh Raman and his friends, a career guidance for young students. You can imagine that these days people can get easily lost. There are so many opportunities. So a career guidance will be wonderful actually. And then, in fact, they have just Venkatesh sent me a newsletter. They have a website called All Career Group. Please have a look at this website and you can download this newsletter. The first newsletter is very interesting. It has nice pictures. For example, there is a conversation with an engineering graduate who turned into a linguist. So, unifying science and, beyond science. And Bosch company, Samuha Purpu Tetatin Mula Marangapudum, Kuriga, Tolu Page, Titam, something in Tamil, and then Quiz Corner. So these are recent effort from Math Science. I'm very happy. So the next example I'm going to give will be surprised, is again our colleague, my collaborator, or Shankar. He's a quantum field theorist, now doing field work in Himalayan glaciers. So it's definitely out of the box science for a string theorist or a field theorist. So Shankar is an honorary professor at Math Science. So he started his PhD career at Tata Institute of Fundamental Research. He was a string theorist, field theorist. His supervisor was Penta Vadia. His PhD work is already well known. Then he joined IIT Kanpur for PDF and Math Science also. And then we are very fortunate that he joined as a faculty member at Math Science. I am particularly fortunate to have a wonderful collaborator because he jumped into quantum condensed matter. So he has done very many works, half term in sigma model, statistics transmutation, exclusion statistics, Shankar and Murthy, relativistic-like effects in graphene with Vinylukos, and the Kitaev model with Saptarshi Mandal and quantum geometry with Hassan. So many beautiful work which are well cited by Shankar. Then there was this famous tsunami in 2014, December tsunami. It overthrew Shankar's interests. So I remember the excitement that Shankar got into because it was a catastrophic natural phenomena, but there is deep and beautiful physics behind it. So Shankar participated in some meetings and so on. Then one of the things that Shankar was trying to do, I think which he also completed, is with available mathematical tools and the techniques he had. So the idea is that there is a major earthquake, let's say underwater, and then it disturbs the water there. And if you know the parameters of the earthquake, how deep it is, what is the Richter scale and various details, how wide it is and so on, you know what is the initial condition roughly. You can use time evolution of hydrodynamics and predict when the tsunami will reach Madras or something like that. So there is enough data about the depth profile because it's controlled by the depth profile of the ocean and using Green's functions and so on. So Shankar got very excited and got into this, and also where to put the buoys and so on. Then soon Shankar was attracted to Himalayas. So he spends 4 months in Himalayan wilderness making measurements on glaciers and studies how global warming impacts glacier dynamics. And I believe that he traveled all the way up to Himalayas by motorcycle from Chennai. But one thing I remember talking to Shankar, that his beard and his the dress and so on reminded the local villagers of some famous leader. So they greeted him with great enthusiasm, thinking that he's that local leader. I forget the name. So now Shankar is a distinguished glaciologist. So going from string theory, field theory to doing field work in Himalayan glaciers is really a out of the box phenomena. So I wish him all the best. And recently, if you know more about what Shankar does, there was a public talk by Shankar. In fact, ICTS has a wonderful series of lectures called Coffee with Curiosity. Now they have changed the name, Curiosity During Quarantine. And Shankar gave a talk on 9th January. It's also related to the Nobel Prize of last year, but it also explains Shankar's, and Shankar has other talks in the YouTube. So I encourage you to look at it. So that's one inspiring example just from nearby. I'm sure people at Math Science must have seen him. This is SVM Sathya. He's a professor of physics at Central University of Pondicherry. He's a very good friend of Math Science. He did his PhD at IGCAR and he was also a scientist. He completed it. And he works on quantum information, nonlinear dynamics, condensed matter theory. So now there was a Hindu article by Shubhashri Desikan of Hindu. Shubhashri happens to be a PhD student of Shankar, whom I spoke just a moment ago. She also changed her direction. Now she is a popular science writer and does extremely well in Hindu. So Sathya says one of the practical problems in science education at the postgraduate level is that the students do not ask questions. Typically, learning is passive, involving accumulation of information. This is well known. Even to add to that, for example, in Tamil Nadu, quantum mechanics and mathematical physics are feared subjects by students. Typically, you take anybody, they will rather mug up some typical equations and some derivations than go into the depth of that, because that's the way they have been taught. It's not their problem. So, and also it's also well known Many students from Tamil Nadu do not pass gate exams and various things. For example, if you take Chennai alone, there are 10 MSc programs starting from Presidency College, Loyola College, Vivekananda College, and so on. You can count. It's about 10. But the number of people getting into research, for example, with math science is typically zero. So 25 years ago, Sathya decided that, in his own way, because they were doing some summer schools at IGCAR. At that time, students were impressed by his talks and requested him, "Sir, why don't you help us?" So Sathya started what is called a Sunday school. So there was P.R. Subramaniam, who was the professor of nuclear physics at that time in the Guindy campus. So he offered him space to teach students on Sunday, free of cost, of course. The students came from neighborhood of Chennai. Some traveled all the way 100 miles. They will travel and come and listen to Sathya and ask questions, discuss freely, work out problems, gain confidence. So this was like, one day activity every week. But it has profound effects. And of course, seeing that, Sathya is doing this, our colleague, Professor Rajaram, Professor H.S. Mani, volunteered, and they also became part of the whole thing. And it was very inspiring. And there are generations of people who have been benefited by this, and some of them are professors now. And similar activity has started elsewhere, in Kerala, in Madurai, and other places. So, like many good things, it has multiplicative effect. So, recently there were 2 nice articles by Joseph Prabakar, who was also one of the beneficiary of Sathya's Sunday class. He's a professor at Loyola College. He wrote 2 articles, one in a blog, bookday.in, and another in Indil Tamil. So those of you who can read Tamil, please read it. You'll enjoy it. So over a period of 25 years, hundreds of students have benefited from the Sunday class. Typically, they are from poor background. About 61% of the first generation graduates, and then about 40% of them are from villages. Many of them have cleared CSIR gate, NET, and other exams. Several of them are well placed, and some are faculty in some top places pursuing science like IIT and so on. Recently, there was a 25th year celebration of Sathya Sunday School. Because of COVID, apparently it was online. I learned from Prabakar. Sathya spoke, of course. Others like Professor Rajaram and H.S. Mani also spoke. I have not watched that video. I did not know about it, so I'm looking forward to it. So Sathya is an inspiring example. Imagine if one man can do, so many things, do at the same time doing his science. It's really an inspiration for us. Okay. Next is the picture you see is a cardiac thoracic surgeon at Chennai Apollo. His name is Paul Ramesh Tangaraj. He was educated. He got his MBBS degree in Stanley Medical College, I think, Stanley or Kilpaw, one of them. Then he went to Cambridge and worked there, and he was invited to Apollo. And he's one of the world leading surgeon. Once I went to a press meet in which he and others from Apollo were there, and some 5 patients were present. They do simultaneously heart-lung transplantation. You can imagine the difficulty. Successful, and now recently has been involved in successful treatment of COVID patients using ECMO. There is something called extracorporeal membrane oxygenation. There are reports about it in the paper, so you can read it. So, how did I come to know Paul Ramesh? Referred to by a common friend. The friend happened to be Venki Venkatesan of National University of Singapore. He was at that time. So Paul Ramesh approached me along with another person with some questions and doubts in physics. It was a pleasure for me to talk to a physician. Normally, you are afraid to meet a doctor. But this time he asked questions. So it was wonderful. Since then, we have been meeting whenever possible and discuss research problems related to blood oxygenation. And he has some hypotheses about what is called sepsis. Sepsis is a condition which happens if there is a major operation. There is a reaction from the immune system and related system, and body's functions start failing one by one, and the whole body swells and so on. So he has some very fascinating hypotheses, and he wants to test his hypotheses using basic science, which he is successfully doing now. He collaborates and publishes research articles with a team of faculty at IIT Madras and our colleague Rahul Siddharthan and Gautam Menon. They have papers together. And even more interestingly, he has a blog. Once he wrote an article about quantum gravity issue, thermodynamic interpretation of quantum gravity. And there was a reference to Paddy. So about 4 or 5 years ago, Paddy was visiting math science. Unfortunately, he's no more. Great friend of math science and us. So I remember Paul Ramesh writing about Paddy's in the blog. So I called Paddy and said that Professor Padmanabhan is visiting math science. You won't believe, in 2 hours he was there at math science. So he had a wonderful discussion with Padmanabhan. So this is also to me an inspiring example. Somebody who is getting excited about physics, working in a very different. So it's definitely out of the box for doctors. Okay. Now, thanks to Manjari, she sent an email some months ago about Manfred Steiner. Apparently, Manfred Steiner wanted to pursue physics as a career, but he migrated to UK, to United States, and he could only become a distinguished medical doctor and medical scientist at the US and worked at Brown Medical School. He had 2 PhD degrees in medicine. He's a very distinguished doctor and medicine scientist. He fulfilled his ambition last year and obtained a PhD in theoretical physics at Brown at an young age of 89. These people are young because they are young at heart, and and the way they are working is amazing, very inspiring. So started taking physics course at the age of 70. He says that at the beginning, students were skeptical whether this old man will do anything. Then slowly he started interacting with them, and slowly he took it easy. And it so happens his thesis supervisor, Brad Marston, is an old friend of mine. And in fact, there's a famous Affleck-Marston phase in RBB theory. Brad was a PhD student during my stay at Princeton. So Brad is very happy with this Manfred Steiner. And his thesis topic was geometrical interpretation of bosonization. In fact, condensed matter colleagues and string theory colleagues, field theory colleagues will appreciate bosonization, non-abelian bosonization, which are popular. So, okay, this is another, out of the box science. Somebody also is an inspiration. At the age of 89, he is doing it. Now, again, another person whom I know very well and many of you know, Deshdeep Sakde. He's a theoretical cosmologist. The first time I met him was at ICTP. He was just returning from the US after his PhD and was very active. He was a postdoc there for a while. And was doing already well known in some of his works are well known in cosmology. So he became a professor at IIT Kanpur, teaching and doing research. Then he has a very strong personality, very strong views, and at the same time he works extremely hard. So he always felt that we should build our own instruments. So slowly that got into his mind. So he began building nano voltmeter, a small nano beginning. And then inspired by IITK, he inspired IITK students to join them. So he started a small operation in Delhi. So students will work for some time, get trained and go. So it's a win-win situation. He traveled to Delhi every weekend and spent 2 days and came back. So he was doing it for a number of years. Recently, I think some years ago, he took voluntary retirement. He has started something called Quasar Technologies, Private Limited in New Delhi. So he publishes research articles based on work done in his laboratory, tries to set up parallel instruments in many laboratories in India and initiate collaboration. His main motivation is something extremely different. Just to give you an example, I will show pictures next. See, scanning tunneling microscope is considered as a very expensive experiment, and very often it is used at very low temperature. And Deshdeep managed to build scanning tunneling microscope at 1/10 of the cost that is available, and also which works at room temperature. Since I am somewhat familiar with scanning tunneling microscope, I visited the Nobel Prize winning lab at met Rohrer and others in Switzerland. So I was very impressed, and it's amazing. If you go to the website quasartech.com, you will see all these very fancy looking instruments built this in a apartment building. That's Quasar Technologies. It's a function, just basically 5 or 6 rooms, and milling machines, everything is there. There are young students and young people, new people. He told me some of the new people can't even speak English. They are graduates from local colleges, or they have done some IT and so on, but they are doing wonderful work. Functioning at apartment building. So these are the kind of instrument, and all of them are room temperature STM, and there is a chemical vapor deposition system which is very important for people doing material science. And one of my colleagues at IIT Madras, Manu Jaiswal, he has bought one and he is extremely happy. In fact, he called me and said that I'm extremely happy with that because it's doing wonderful work. and the cost is 1/10 of the thing. So he has built computational kits to deal with complex realistic situations in nanoscience. For example, there is a lot of excitement about viscous electrons in graphene. So viscous electrodynamics in graphene he could do using his packages. And he has done STM Meyer pattern graphene and charge density, a famous star of David Onti in tantalum disulfide and so on, and he's publishing papers. So I thought I should give this example because it's very inspiring. I wish I could do, because I'm a condensed matter theorist. I can't even tighten some screw properly. But here is a cosmologist. He has gone completely in a different direction and making. In fact, some of you may remember he gave a colloquium at Math Science, and he gave one at IIT Madras, and then he travels these days, and he is trying to revive this kind of activity all over the country. Okay. Then this is another friend. Many of you know him. He's also a very good friend of Math Science, Vikram Soni. I mean, people say that whenever Vikram is around, the place looks very, bright and joyful, because he has lots of jokes and he's a very happy man. So Vikram, got this very enviable position called UGC professorship. So UGC started some scheme and they made some people professors, so they can be anywhere they want in any university system. So he decided to spend a lot of time at NPL, and then sometimes at JNU, and then later at Jamia Millia. So how did I meet Vikram Soni? Thanks to people like P.M. Matthews and Rajasekaran, particularly Rajaji. So Department of Theoretical Physics in the 80s was a very amazing place. It had a national character. Normally, if you go to a typical department in the University of Madras, there will be Tamils and maybe some neighboring people from Kerala, Mysore or something like that. Here you found Vikram Soni from North India, Jatinder Bajaj, and M.D. Srinivas, M.S. Sriram from Karnataka, S.D. Rindani from Gujarat, and people like that. So it was a very eclectic place, and very lively and very. So that's when I first met Vikram Soni, and we became collaborators and friends. And it's at that time students like T.R. Govindaraj and Jayaraman, Jayalakshmi, Lakshmi Bala, Sivakumar, Murugan, they were all there. And we used to have outstanding visitors. I remember Professor S. Chandrasekhar spending a week at Department of Theoretical Physics. So apparently, Indira Gandhi invited him to come to India. He said that I will spend 1 week in Department of Theoretical Physics because they are doing well. So he spent 1 week and discussed with us. I remember still famous S. Chandrasekhar, Nobel laureate, discussing with us at Department of Theoretical Physics. Met Professor M.S. Raghunathan, gave a course of lectures on algebraic geometry and things like that. Professor H.S. Mani talked about non-perturbative methods. It was wonderful. So thanks to Rajaji, I got introduced to these people, and it was a wonderful time. And then Soni, he passed out of MSc from Delhi University, went to University of California, Santa Barbara, finished a PhD, and then went to Sussex, did a postdoc, and then came to Theoretical Physics Department. And so Soni builds these days for the last 10-15 years bridges between science, conservation, and wisdom. So Soni's point is to work with the planet, we need to know how the planet works. So he uses all his physics skills to understand how the planet works. So his work started what is called Aravali Biodiversity Park in South Delhi. Like I show the picture in the next. So if you look at the Indian map, we have beautiful mountain ranges, Western Ghats, and Vindhya, and also Aravali. Aravali is a old. It's 1.5 billion years old in comparison to a young Himalaya, which is only 50 million years old, according to geologists. So this Aravali stretches, and actually Delhi, New Delhi is, people from Delhi will appreciate it, is part of that, actually was part of that. So still there are remnants of it left, which are called ridges spread all over Delhi. They are beautiful places. If you go inside the ridge, you will feel as if you are in a forest. So Delhi Ridge is part of North Aravali, and I think I encourage you to look at some of these things when you have time. And there are beautiful photographs, like for example, this is the Aravali in Rajasthan. I have never been there, but I wish I could go there sometime. And then now the biodiversity park that is right there in Vasant Kunj area, Vasant Vihar area. When you go from airport to, for example, INSA, you will cross that. It has beautiful peacocks. It has this kind of birds. It has special squirrels. And it has kind of fox-like animals and beautiful water bodies and waterfowls and all kinds of animals. It's a beautiful place. You won't believe that such a thing is there in Delhi. In fact, partly it is true with Chennai also, but unfortunately the amount left is very small. We have about 500 acres, which is part of Raj Bhavan and IIT Madras. Then we have about few hundred acres, which is part of this Adayar Theosophical Society. Elsewhere, all the forests that used to be there have disappeared, unfortunately. So if you go to parts of Theosophical Society, it looks so natural like this. There are some little nice animals. So I encourage to people to visit IIT Madras and also Theosophical Society for its own charm, just the natural charm. And I hope it survives and it grows into even more things. What happened? Like elsewhere in our country, nature was disappearing fast in the biodiversity park. Malls, hotels, army construction started happening. Sony and colleagues. Sony is a kind of fearless fellow. He can talk to anybody convincingly and he was not afraid of being threatened and so on. Sony and colleagues fought for more than 10 years to preserve the precious natural reserve sitting in the middle of the city. So attempted a separate effort to preserve banks of Yamuna because there were some big construction related to Commonwealth game and so on. So these guys were partly successful because of good judges and so on. So they filed petitions and worked very hard and managed to save 1/3 of the park. Now at that time, Sony started thinking about water and natural water bodies, aquifer, floodplains and so on. Then he also gave a course on citizens course on public interest in science at JNU. Now, if you want to know more about Sony's activities, see, many of the friends at whom we know personally, we take them for granted. But what they have achieved and so on is amazing. So you should look at the TEDx talk by Vikram Sony, Building Bridges Between Science, and he has many other. And just a 15-20 minutes, it will tell you the spirit of what he is doing. Now, at some point, Sony started a foundation called Public Interest Science Foundation, PI Science in the Public Interest. It immediately attracted very distinguished people like Professor M.S. Swaminathan. He is one of the founding members, and Professor Anthony Leggett, a Nobel laureate, a good friend of Vikram Sony and us. He gladly agreed to be part. And then Rajendra Singh, the waterman, and Arvind Birmani, who was in World Bank, and among others. So there is a website, Science in Public Interest. So it's worth seeing actually because it will give you an idea what these people are doing, which is unfortunately not well known. For example, one of the pet idea of Vikram Sony, which took shape some years ago, but then because of political thing it stopped, but it's still there. It's a very precious direction. So the idea is the following. So we are all starved for good water in Chennai, for example. So I knew that the rivers exist. Then I did not know about floodplain, and floodplain is a remarkable phenomenon. So in the sense, if there is a river, manifestly outside you see water flowing, but implicitly there is a lot of body of water, sometimes 50 meter, 100 meter below the river, it's full of sand, which also carries water. Similarly, that sand spreads sometimes for a kilometer on both sides of the river, or even more. Famous, I'm not talking about meandering rivers, even ordinary rivers have a large floodplain. So Sony started thinking about the floodplains in Yamuna in Delhi, and then doing some experiments with the sand and put water. And then he found out, he came up with a very beautiful idea. He has written several articles. It's there in his website. So floodplains of rivers can provide a new source of water. They are local, non-polluting, perennial, and non-invasive source of water for urban centers because you take them out and then they get replenished during the flood time. So, it's a win-win situation. And our work, so they did a research work with the Delhi Jal Board and it started in a big way over a stretch, 25 kilometers stretch it was running. I do not know what exactly happened, but it's fascinating because, in fact, Sony 3 years ago, he came to Madurai. In fact, I accompanied him. He spoke to the people who are, village communities and so on, inspired them to think about it. And he offered to help to do similar thing in Tamarabarani River, the southernmost part, as a test case. So I do not know what it is now, but it's a fantastic idea. So because Sony thought about aquifers and the sources of water. So this is the least invasive way in which you can take, instead of tapping groundwater arbitrarily, try to focus on floodplains, and that's a big source of water. He has estimated, being a physicist and also trained in the US, so he was very quick in making estimates, and he's not afraid of numbers and making calculations and so on. So yes, and we have shocked the geologists and people working on this kind of field by intuition and estimates. So this is what it is. So then what did Sony do? So in fact, there is an article in Deccan Chronicle, for example, you can remove Tamil Nadu water crisis. Then Subhashri has written an article in 2017, Amravati could become a prototype of building cities. And so if you look at Sony's the website, what you will find is several things. I think, let me see, I have forgot to write that. He has focused on several things. One of them is something on natural cities. So this was a fascinating thing, because I was, when it was being developed, he used to tell me about it. So I was very fascinated. So you may remember some years ago, the capital of, they wanted to build a city on the banks of river Godavari, which was a very fertile land on both sides, very good crops and so on. Now you want to build a city. So Sony got very excited. This is an opportunity. You can make the city a natural city. So he worked closely with Romy Khosla. Some of you may know, he's a very distinguished architect. And they wrote a book in the form of a proposal. And in fact, when Professor M.S. Swaminathan saw it, he was so excited, he immediately called the Andhra Chief Minister, then who was going to be involved in this. I forget his name, my God, it's terrible. So, and told him that you should. So the idea is the following, that is, anyway we are going to build a city, so that cannot be avoided, but let's make as best use of nature as much possible. Just to give you one example, his city. So, for example, imagine you have a forest, then you are forced to build a city. So, in a scale-free way, like suppose the stretch is 15 kilometers, separate them into things of dimension 1.5 kilometers. Within the 1.5 kilometers, separate them, so that you have concrete buildings coexisting with nature. And it's not a, it's a very seriously thought about plan, and he has worked out numbers and so on, and it could be done. It's not a fancy idea. So he spent years thinking about it, and this book actually incidentally can be downloaded from Sony's website. So this is to me very amazing, that something that he can do. But unfortunately, I think this did not happen. A standard city has come there. But according to Sony, there are more details about possible. So who knows? Maybe somebody else will take this up in future and build natural cities. Okay. Now, Sony has written a book, naturally. Vikram Sony has for many years been a leader in the fight against the destruction of the natural environment in his home country, India, and elsewhere throughout the planet. In this book, he describes some of the exquisite balance which nature has evolved in the course of Earth's 4 billion year history, and makes an eloquent plea for a kind of technology much more respectful and symbiotic with them than what we have today. Sony has been coming up with viable alternatives and continuing his efforts as described in the website. Let me let me tell a real incident. So Sony, when we were in Madras, we used to be fascinated. We used to go to the beach together. Once we walked from Chennai all the way up to Kovalam, about 20 miles up and down on the beach. It was a wonderful experience, going through the villages and so on. A memorable experience, which when I tell the Chennai people, they don't believe first, is that once Sony and myself were standing on the beach near Thiruvanmiyur, we saw at a distance dolphins jumping out of the water and going, a school of dolphins. So we immediately approached a neighbor who was a former village fisherman. He said, Amasara, you call it as Veduva mean. Sometimes it comes, most of the time it's far away, a few kilometers. So for him it was natural. So whenever I told people, they didn't believe it. Then I have seen this in 3 other occasions. Once we saw with my grandchildren 3 dolphins playing in Kuttivakam beach. And then once we approached them, it went away. So nobody will believe it, it happens. Apparently dolphins are plenty in Pondicherry. They travel for scavenging in our Chennai port. So sometimes once I met a person who works on marine biology in Tamil Nadu and in India. He said, white dolphin, you just go 10 kilometers away, you can even see whales very commonly coming and coming in this area. So thanks to Sony, that knowledge I got. Anyway, so now the next friend is Subbi Arunachalam. Many of you know him because Arunachalam used to come to Math Science regularly. Even spent, Balu may remember, Balu was very kind enough to offer him a visiting professorship. He was there for a year once. So Arunachalam is a well-known information scientist and scientiometrist. He was at CSIR to begin with and came to IASC for a PhD. And then quickly went to Indian Academy of Sciences. Then he was Secretary, MSSRF and so on. So currently he is a distinguished fellow at the Center for Internet and Society, Bangalore, visiting professor, DSCPRIS. So he did his MSc at Annamalai University. And how did he become what he is? So this is the story, it's out of the box. So he moved to IASC for a PhD in electrochemistry at the Department of Inorganic and Physical Chemistry Department. Then he was doing very well, in fact, according to my colleagues. Then his mind, he had a different call. So he became a founding editor of Pramana at the Indian Institute of Science, Bangalore. Professor Ramaseshan was the academic president and so on. He was very happy to have Arunachalam's assistant. So then very quickly, Arunachalam was attracted to scientiometrics and open access movement. This is something very interesting because, most of us practice science. We focus on our science. But science has evolved over a few centuries into a very different big animal. There are more people practicing science and there are more possibilities of misuse of, way science is propagated and so on. So Arunachalam became sensitive to that. So he decided consciously that he will start scientiometrics in India. That is basically measuring the impact of Indian science, for example. It's called scientiometry. Then in the process, he got involved in open access movement. I will tell about it. So anyway, so this is what Arunachalam is. So now he is a visiting professor at Department of Science and Technology, Center for Policy Research. In fact, for the last 2 years, he has not been moving because of Corona. So it says globally known for his expertise in scientiometrics and their use for assessing the research impact on a wide scale of ranging from individuals and departments to institutes and countries. So he's very frank actually. So he has angered many big bosses in the country, but later they agreed with him. His interests include scientiometrics, science policy, information science, public understanding, and so on. He was instrumental in CSIR, DBT, and DST adopting green open access as official policy. Okay, so now why somebody doing electrochemistry should go to this open access? As I said, the science that we practice is big, so we need watchdogs, so to say. We need people who will take care of the publishing mode and so on. So most of the young scientists in recent times take open access for granted in science and related issues for granted. In fact, if you want to learn about open access, we keep it as a beautiful, long article. Many are unaware of the history of the silent revolution for nearly 4 decades. Fortunately, I am aware because I knew Arunachalam for a long time. Dedicated work of dedicated people, scientists and non-scientists, how it continues to help science and scientists. There are, multinational predators and predatory journals who are willing to make money out of the science that you and me do from people's tax money. So, for example, not many modern day scientists are familiar with Paul Ginsburg, an amazing guy, high energy physicist, who used to be at Los Alamos National Lab and then later at Cornell. He's a professor there, who started the widely and well-used preprint archiving. You won't believe, when I was at Madras University, archive was not there. They used to send preprint list every week. And then you write to the author for a preprint if you find something interesting. Now the archive is 30 years old now. We don't appreciate how powerful it is. It has gone well beyond high energy physics into most of physics, experimental physics, recently into mathematics and bioscience and so on. So we take it for granted, and of course, thanks to internet revolution, many of these things have merged together. But there are people like who Arunachalam have been working silently from behind. So that's why I wanted to bring them. So that was their call. They were regular scientists, but they had a call, and then they do it like the way Shankar had a call from Himalayas or tsunami. So now recently, last couple of months ago, the DST, Center for Policy Research at IAS, celebrated India International Open Access Week. So on this occasion, Arunachalam was a special guest. Meeting was actually centered around Arun's 80th birthday. Arun, a young man, is just completed 80. So I encourage, if you have time, please have a look at this YouTube. If you do a simple search, you will get it. You don't need to note it down. Open access week. So the three speakers were Professor Balaram, former director of IASC. So Balaram starts by saying that when I got the invitation to talk in the open access week, I hesitated. Then when I heard that Arunachalam is going to be honored, I said I will gladly accept. So he gives 30 minutes talk, 15 minutes elaborating Arunachalam's contribution, because he has closely watched Arunachalam and benefited by his open access. And he's a very nice, and also there is an article talk by Heather Joseph, Executive Director of Spark IASC, and also Leslie Chen, Professor from University of Toronto. So this YouTube was kind of eye-opener for me about various issues in open access, which we take for granted. Just to give you an example, which you are very familiar with, I will come back to it. For example, there is an article which says how in not long back, 1990, there was only one journal, Nature, and then there is one journal, Science. Now all of them, you see, they have, of course, science is growing, but not at the rate in which journals are multiplying. So somebody has written an article, branding spin-off scholarly journals, transmuting symbolic capital into economic capital. So there is money involved. So multinationals and even academies, get confused and things. And we are not sensitive to this. So these things are discussed. I was very happy to listen to some of these things, which we are not aware of, because as professional scientists we are focusing on our science. But we have these watchdogs who are watching and who are helping us from behind. So it's very important to appreciate that. Okay, so this is Balram's talk. He starts by talking about Subbiya Arunachalam, and then how he and Eugene Garfield worked together, and Ratnakar, who retired as a librarian from Raman Research Institute, and Sathya Narayana. It's a very interesting 30 minutes talk. And similarly, Leslie Chan, a pioneer in open access, he pays a tribute to Arunachalam in a very beautiful way. So I encourage, if you have time, please look at it. Okay, now next home. Okay, so I have 10 more minutes. I'm doing well in time. So this is Mike Lazaridis. You all know that before iPhone became famous, there was a BlackBerry cell phone, and it's the beginning of the revolution. So this is Mike Lazaridis, chief of BlackBerry. He's a multi-billionaire. So apparently when Mike was young, he wanted to become a quantum scientist. Then I think he dropped out of his course. Then poor guy, he could only become a billionaire by establishing BlackBerry cell phone company. And he also established something called Research in Motion. But deep in his heart, because I have met him and talked to him, and so I know him well. So the ambition stayed in his mind. One day he met somebody by name Howard Barton. So Howard Barton finished a PhD with a friend of mine whom I know at Waterloo University and Perimeter Institute in gravitational theory. So he wanted to pursue research in gravitational theory. He applied for positions, job, he didn't get any, whereas he got jobs in Wall Street and stock markets and so on. So he heard about this cell phone company having a semiconductor lab called Research in Motion in Waterloo, with the place where he comes from or nearby. So he wrote to Mike Lazaridis saying that I don't want to give up science. I will become an experimentalist rather than go to Wall Street. And because it's new to me, I will learn this. So Mike was impressed by this letter. So he invited him for a lunch. So they discussed over lunch. So his passion. So at the end of the lunch, Mike took a piece of paper and wrote $100 million. And here is $100 million. It's for you to start an Institute of Theoretical Physics, because I have enough money. I can spare $100 million. But you can't touch that $100 million. You'll have to raise equal money from the federal government, because you seem to be very familiar with the functioning of governments and so on. So take it as a challenge. So he said, please give me a time. So Howard Barton thought about it for a week and came back with a proposal including the name Perimeter Institute. So Mike Lazarus, being a shrewd businessman, said, yeah, it's good, so please go ahead. That's the beginning. So Howard Burton traveled to the Institute for Advanced Studies, first spoke to Dyson, then Ed Witten and others, and then flew to Canada, Cambridge University, and talked to people. And then that's the beginning of Perimeter Institute. Now there's a very interesting book called First Principle, Building Perimeter Institute by Howard Burton. He served as a director, founding director for 10 years. His passion was different, like writing books for children. I think he settled somewhere in France. So this is the beginning of how he went out of the, in his profession, he went into this. So Mike Lazarus now, Waterloo, Canada has had research in motion, a functioning semiconductor lab in connection with cell phones and so on. Then Perimeter Institute for Theoretical started, outstanding place. I encourage you, those of you, if you are passing by Canada, please visit the Perimeter Institute. And if you want to spend some time, you can, because I have a close connection with them. It will be wonderful actually for, we even have at Math Science some memorandum of understanding with the Perimeter Institute. So he started Perimeter Institute with a $100 million endowment. Then Institute for Quantum Computing at University of Waterloo, the University of Waterloo Quantum Nano Center, and then Center for International Governance Initiative. This is something that I want to emphasize. This is just 100 meters from Perimeter Institute in Waterloo, and you can see Mike Lazarus and one of his partners, they spent about $20 million each and started this. Here what they have is, they have outstanding economists coming and spending some time and addressing global problems of linking rivers, problems of weather, climate change, and all kinds of things, and they come up with concrete solutions. Some of them are taken, and their point is, even if out of the 100 solutions that we offer, if one gets approved, nation will benefit. Apparently, one of the proposals they gave to International Atomic Energy Agency got restructuring suggestion got accepted, and it's doing well. So that's again. So in fact, once I gave a talk about it somewhere, I don't remember. Our rich people should do this because we are billionaires. Center for International Governance. So this is when I met this great man from Bangladesh, Muhammad Yunus, who got Nobel Prize, who started this, helping the poor people. Amazing, very inspiring talk by. So they invite people like that, and they take challenging problems, addressing the globe, and try to solve it and come up with. And it's according to Mike Lazarus, it's a very cheap initiative, just $40 million, and it's functioning well. I'm sure 40 million is nothing for many of our billionaires. So this is Perimeter Institute. It's a beautiful place, located by the side of a Waterloo Park, and you can see swans in spring, and that's Perimeter Institute. And there is an extension which is called Stephen Hawking Center. In fact, Stephen Hawking used to come regularly there, and so it's like math science actually, because I feel very at home at Perimeter because it's very eclectic. The number of faculty is very small, but there's extensive visitor program, and also they have something called Perimeter Scholars International. In fact, I was talking with colleagues at Math Science 10 years ago to mirror it, but okay, we should talk about it again. What they do is they take about 40 students from all over the world, from developing countries, people who get good recommendations. They may not have good background, but if they are motivated, if the professor says this fellow is outstanding motivation, then they invite them. What do they do? They put them together and they listen to outstanding lectures on string theory, quantum mechanics, complex variable theory, this and that. And there are no exams. So in the morning there are lectures. In the afternoon, students sit together along with few tutors and work out. They work out problems, discuss. And at the end of 1 year, a student from Philippines become outstanding and he is going to Harvard. So it's a kind of miracle-making program called Perimeter Scholars International. I encourage many of our students to look at it. And then if you talk to Mike, it's amazing that how he says the whole society should be thankful to Maxwell and theoretical physics because of simple Maxwell's equation. You remember Maxwell's equation? It was a synthesis of Ampere's law, Biot-Savart law, and Gauss's law, and so on, into a unification into a calculus form, into a form of differential equation, which predicted existence of electromagnetic waves, and the world changed. And it was found out experimentally by Hertz and so on, and Bose, communication, J.C. Bose. So he says, the society is indebted to theoretical physics forever. So I'm very happy to hear it from a billionaire, but I wish many other billionaires do that. Anyway, we have examples in India, like Mahendralal Sarkar many years ago laid foundation for Raman to flourish in the soil of Calcutta, Tata Alagappa in Chennai, Alagappa College, and AC, he gave land for Sikri in Karaikudi, Birla, Mehta, Annamalai, Alagappa, many people, recently many new people. Good. So now let me, I have I think about 5 minutes. So just next door to math science, now if students are bold enough, they can climb over the wall of behind the hostel and they will land at MS Swaminathan Research Foundation. He's an inspiration. Professor Swaminathan is 96. He started as an agricultural scientist and geneticist, and he was involved in green revolution in India, and now he's talking about evergreen revolution. I met him just before the COVID. I had a very long chat with him. Very nice. He was not feeling well because he had some problem with his leg, but his face was bright and he was full of ideas as usual, very optimistic, positive, and so on. So the foundation aims to accelerate use of modern science for sustainable agriculture and rural development. So this is, in fact, I came to know more about this Swaminathan Institute because Subbi Arunachalam worked there for 10 years, and he did wonderful things. It attracted people like some very distinguished biologists from the US, many of them. So, for example, if you look at coastal system research, information education research, and conservation of biodiversity, several regional centers. So they mix science, basic science, and application in a very beautiful way, in a very novel way. For example, this is something always fascinating. I do not know how many of you have been to this mangrove forest in Pichavaram, south of Pondicherry. It's a wonderful place. What you see is the seawater. And there are these trees which live in the salt water. They are very special trees. Their evolution is very different. And you can find a disappearing mangrove forest on the banks of Adayar River estuary adjoining Adayar Theosophical Society. So before it encourages, disappears, I encourage students of math science or people who can go, please visit Adayar Theosophical Society and go to the backside. You will still see some left out mangrove forest because Adayar, the river has been polluted by so much. It has kind of strangled them, but still something is left. And the group of MS Swaminathan are doing wonderful work in that. So to me, this is also an amazing thing that a basic scientist, a geneticist, coming out of the way and doing this wonderful thing out of the box. Let me see. So they have, now I think I've just completed the time. So there are many inspiring examples, like Professor Rajaram. I can give any number of talks. He was a high energy physicist. In fact, he was my teacher at IISc Bangalore. And thanks to Professor Rajaram, he gave a course on field theory, and he made, because I was afraid of field theory and d mu and mu notations, which is familiar to high energy physics. He said, Baskaran, that's nothing. Just, he gave a very friendly course, which made me to think about gauge theory and so on. So he's an inspiring teacher. Now, Professor Rajaram has gone from high energy physics to complete nuclear disarmament. He's part of this, we must forget the name. And, there are these clocks about when will there be a nuclear explosion and so on. So there are many outstanding people all over. So let me complete by making a request. So it's wonderful if the people I spoke about could be invited to give talks about the out-of-box efforts as scientists. Incidentally, I have not told any of my friends that I'm giving a talk because it will be embarrassing for them and for me. So I will now, of course, tell them they can see the YouTube. So many of the outstanding people I described in my talk today are selfless and working independent of any support they get from the system. And math science is kind enough to give a chair and table post-retirement at 60. And we have a terrible thing, we are retired at 60 or 62 sometimes. And it's terrible, I wish I can talk to you. Because people, these days, science is becoming complex. You reach maturity at the age of 70 or 75. I really believe that I am yet to receive my maturity. So to retire somebody at 60 is terrible. Anyway, so on the 75th year of independence, government should think about this anomaly. It's a big anomaly in our country. I've been telling, government officials and high people in the government. But again a plea. But leave the government. There are billionaires abound now, in Bangalore and Chennai. There are many private houses, industrialists, wealthy alumni who could make a difference to Indian science. So those of you who have wealth, please create endowed chairs. We'll be helping Indian science and our nation on the occasion of 70th year of independence and beyond. So, the kind of, once I gave a talk in the Prime Minister's office in Delhi. Of course, Prime Minister was not there, but Professor Chidambaram was there. He was the scientific advisor. So the thing was about the future of condensed matter physics. So I was asked to be the first to talk. So I told them that before you talk about the future of condensed matter physics, you should talk about future of condensed matter physicists. I gave about 20 names who will get job just outside India, in the US or Europe, very easily, but who will be thrown out next year because they are reaching 60 or 65. So I told them you should do something about it. Anyway, so now I have found that beyond government, there are enormous wealth available in our world. Like if you take Bangalore, there must be at least 20 billionaires. And to create a chair to one of these things is nothing. It's peanuts actually. And in the process, they will be also gaining name. For example, if you take Shastra, a great engineering institute, it's more famous because of the Ramanujam award that it has created. The Ramanujam award that people got, they have become Fields medalists, many of them. So it's a win-win situation. It's enlightened self-interest. So I request wealthy people to create chairs, and because you have talents, who are just maturing at the age of 16, and you throw them out. Okay. With that plea and request, let me thank you for your attention. Thank you, Ravi, and now the chair is yours.
Thank you, Professor Baskaran, for wonderful talk and also inspiring to all of us. I think the session is open for questions, comments.
This is not a question. May I?
Please, yeah.
Yeah, it's not a question, but I think a great appreciation for a wonderful talk that Baskaran has given. I particularly enjoyed it because almost every one of those people are people whom I came across while I was in Institute of Mathematical Sciences and elsewhere. And wonderful collection of out-of-box solutions that should be familiar to us, but was not. Thank you very much, Baskaran.
Thank you. Yeah, I always say that if I give a talk in India, nobody asks questions. But when they come out of the lecture hall, students throng, they ask questions. So this is a very strange phenomenon in India. Students may have questions in their mind, but they will be kind of keeping it in their mind. Unfortunately, I can't come there unless somebody teleports me from Los Angeles to math science.
Yeah. Can I also make a comment actually, because I take this opportunity? Professor Baskaran, I recall, Professor RR's Mrs. was involved in educating kids of, construction workers in IIT Kanpur school, and it is actually now grown up as a big school, and that was also, she is also one of the inspiring.
In fact, thank you, Ravindran, for reminding.
Yeah, another person is Rukmini from, from ICTS, and she was at HRI when I was a faculty over there, and she used to actually set up, collect kids from the nearby village, Junsi village, and set up a, kind of a library, collected books, from people, and then these kids were asked to come and spend time in the evenings during weekends and things like that. That was also a wonderful effort by her, actually inspired the young kids to get exposed to research institutes, and that was an inspiration for many of them actually.
Correct. So, I totally agree with you. There are many inspiring, out there in the big world, there are many more such inspiring examples. It's good that you brought Mrs. RR, because I was talking about her just 2 days ago with some friends over phone. See, for people who do not know about it, I wanted to tell. I think Professor RR settles down in IIT Kanpur as a young professor, and Lakshmi is her name, right? Is it?
Her name is Vijaya Ramachandran. Yeah. This is an organization called Jagrati Bal Vikas Samiti, in which several of our people from Department of Physics are also involved in it. And I think in some sense, this is something that they attempt to see that children of highly underprivileged section can be as much inspiring as children elsewhere. That's it.
Right. So apparently, she started with construction workers as IIT Kanpur, and she started school and it has grown into amazing thing. I was recently with somebody in the context of, he was mentioning about Kamaraj. I remember either RR or Vijaya telling me that when Kamaraj used to, because Vijaya's father was a minister in Tamil Nadu, Venkataraman. So Kamaraj was the chief minister. At that time, apparently Kamaraj told the children, Venkataraman's daughters, that you should give Kalvi Kan, that is a vision of education to poor children. Please keep it in mind. So this is something that I heard. So they were also partly inspired by people like Kamaraj. In some context, somebody was telling me. Okay, sorry. Yeah, there are many examples out there in the big world. In fact, I wanted to write here a famous Tamil poem called Undalamma Ivulagam. That means, please note it down. Undalamma Ivulagam. That the world is living, world is what it is because of good people whom we do not know. There are many good people there. Otherwise, the world would have disappeared long back. So, thank you for listening to my talk. And so I looked at the chat box. I don't find. There is a general question. Hello, sir. I have a general question. What do you think about promoting the ideas of basic science to the general population? What I think is that in this era, we greatly depend on the technology. It is necessary to understand them. This is John Paul to everyone. So he is talking about promoting the ideas of basic science to the general population. It's a very good idea. It's our duty. For example, people like Carl Sagan and many others told about the importance of astronomy as a basic science to modern society. And so there are every aspects of basic science is going to be in turn in the long run is going to help society. Like who thought that Maxwell's equation bringing the laws of electromagnetic together into unified theory will help society. So any sincere attempt to understand nature in a basic science fashion always helps. So this should be conveyed to the public. I totally agree with you. And I think math science is doing its best to do it in many ways. And it should be done more. I totally agree that is importance of basic science. And it's now that there is this internet facility and so on, it should be done more. I agree. Yeah, I think that's my answer to John Paul on the technologies necessary to understand. So his point is basic science is necessary for the technology. Very true. Yes, we should do it. I agree.
Yeah, thank you, Professor Baskaran, for wonderful talk, and we will have more about it actually when you're back in the institute in live in our auditorium. So I thank you again for agreeing to give this talk and inspiring all of us. Thank you again. Thanks to everybody.
So let's keep in touch. Thank you very much. And have a good day.